Is my voice clear? Hello? Hello?
Yes, sir. Can hear now. I can hear now, sir.
Okay. Can you hear me now?
Yes, sir.
Okay. So we will discuss the electric field part of AS level also, because I know that you have not much idea of what is the electric field and what is Coulomb's law. So without that we cannot finish this one. So I am covering all, okay, because this both the topics, first in the AS level and in A level, are dependent. For understanding the A level topic, you have to understand the AS level topic of electric field. I am talking only. So we will start from the electric charge. Okay. Okay, now electric charge. First topic is the electric charge. So like there is mass. Mass is basically what? The quantity of matter contained in a body is mass. And what is weight? Shafdin, what is weight? Actually, your voice is very, very slow.
The weight is basically like how heavy the mass is, right?
No. How heavy? No. Actually, for weight, what is weight? Is a gravitational force acting on any mass. Weight is the gravitational force acting on any mass. Okay, so that is the weight. Okay. So basically, by the way, we are coming back to our topic. Mass is the quantity of matter contained in a body is mass. And I told you that in the previous chapter, that is gravitation, I told you that if two masses are there, suppose these are two masses, they will attract each other due to gravitational force of attraction. Masses. So in the gravitation chapter, we have studied about the masses. In this chapter, we will study about the charges. In this, we will study about the charges. Okay. So let us start with charge. So do you have any idea about the charge? Two types of charges, positive and negative. There are two types of charges, positive charge and negative charge. Okay. So I have written here the definition of the charge, you can say. Exact definition of charge we cannot define. Exactly we cannot define charge. But here is the definition. You can say this is approximately correct definition. So charge is a property of a matter due to which electric force, electric fields, and electric energy produced, and charge is of positive and negative. Two types of charges are there, positive and negative. Positive and negative. So two types of charges are there.
So
Hmm?
are you writing down anything, or
What?
are you writing anything? Because your screen is
Oh, my screen. Okay.
it's still in like the content page.
Now it's okay.
Yeah, now it's okay.
Okay. So charge is the property of a matter due to which electric force, electric field, and electric energy is produced. We will study about the electric force, we will study about the electric field, we will study about the electric energy also. So there we will study, there we will study that due to the electric charge, there is electric field. Like due to the mass, there is gravitational field. Like that, due to electric charge, there is electric field. Okay. In the chapter gravitation, we have studied due to masses. There is a force between two masses. There is a force between two masses. Like that, there is a force between charges also. So due to charge, there will be a force. In masses, we have seen due to any mass, we have seen the potential energy of gravitational potential energy. We have seen gravitational potential energy of this of a system. Here also, due to charge, there will be the gravitational potential energy. We will see. So basically, charge is a property of a matter due to which the electric force, electric field, and electric energy produce. Okay. So charge are of two types, positive and negative charge. And charge is a scalar quantity. Charge is a scalar quantity. Scalar means to define the charge, no need to define the direction. Charge is simply charge. There is no direction of charge. We do not define the direction of the charge. What is the SI unit of charge? Coulomb. Coulomb. Coulomb is the SI unit of charge. For example, SI unit of length is meter. S, the SI unit of charge is Coulomb. Okay. Now, if two positive charges are separated by some distance, suppose this is one positive charge, and charge we will represent with Q, small q or capital Q, we will represent the charge. Okay. Represent how we will represent the charge, small q or capital Q. Sometimes we will represent it with capital Q also. Charge. So these are the two charges, and these two charges are separated by some distance r. So r is the distance between two charges, and this distance you will take from the center of these charges. Okay. Center of these charges. This r is basically the distance between the center of one charge and the center of another charge. So if both charge are positive charge, then they will repel each other. If both charge are negative charge, again they will repel each other. If both charges, one charge is this, another charge is this, if they are opposite charges, so they will attract each other. Okay, so they will attract each other like this. When similar charges repel each other and dislike charges attract each other. So here is the force of attraction. Force of attraction will be there. Okay, so to find the force between two charges, okay, there is a law known as the Coulomb's law. So tell me one thing, if there are two masses separated by some distance r, what is the force between these two masses, m1 and m2? m1 and m2 are two masses. The force will be the gravitational force between these two masses, and this force will be the attraction force, and this force is given by g into product of mass m1 and m2 divided by r square. Similarly, when there will be two charges, here one charge is placed and here another charge is placed, q2. So the force between two charges is given by k is a constant, q1 q2 divided by r square. And here this force is always attractive. This force is always attractive. This force can be attractive and can be repulsive. And this force is what force? Gravitational force between two masses. And here this force between two charges is known as the electrostatic force. Electrostatic force. Electrostatic force. Or you can say this is gravitational force, or you can say this is also known as electric force. Okay, so to define the Newton's law of gravitation, how we define the Newton's law of gravitation? Newton's law of gravitation says that this force F is directly proportional to the product of masses m1 and m2, and this force is inversely proportional to the 1 upon r square. Similarly, here in Coulomb's law, we will study, this is Newton's law of gravitation. Coulomb law. In Coulomb law, we will see that this electrostatic force between two charges is depending upon the product of two charges. Here, depending upon product of two masses. Also, it is depending upon 1 upon r square. Okay, but here the force between two masses is independent of the medium between two masses. No matter in between these two masses there is air, there is water, there is oil, any other medium. So this gravitation force will remain same, but the electrostatic force will change when you will change the medium between two masses. All the things will remain same. Here also this is a central force. This is also the central force. Central force means this force means the gravitational force, we know that acted along the line joining the center of two masses, or it can be also it is acted along the line joining between the two masses. Say in the same way, here the electrostatic force will always act along the line joining between the two charges. Okay, so now let's discuss the Coulomb's law. So basically Coulomb's law is this. Suppose this is one charge, this is another charge, Q1 and Q2, and in between these two charges there is any medium. There is any medium. Medium means this medium may be air, maybe water, maybe some gas, maybe oil, and maybe any other medium. Okay, so these two charges are separated by some distance, which is r, and these two are the point charges. Remember, point charges. These two are point charges. As compared to this distance, this charge is very, very small. As compared to the distance, what is the concept of the point? I told you na, point masses. What is the meaning of point masses? Okay. So point charges means na, suppose what I told you about the point masses.
It's like a body where in which
Means point masses is basically the concept depending upon the distance. For example, if there are two masses, 5 kg and another mass is of 6 kg, and they are separated by 10 meter. No, they are separated by 10 meter, or you can say they are separated by 1 meter. So in this case, these masses are not considered as point masses. But if these two masses, one is 5 kg, another is of 6 kg, they are separated by 10 kilometer. So if this is the distance, mean these charges are very, very, very far apart. When you will see not charges, when you will see these masses will be, when you will see, suppose from here, or from this mass, you are seeing this mass, that is 10 kilometer away from this 5 kg mass. So this mass will become very smaller and very, very small in size for you. So basically, for your observation, this mass will become as a point mass. But when here is a 6 kg mass, okay, understand? Once again, I am telling 5 kg and 6 kg are 1 kilometer, 1 meter apart. And suppose you are on this mass and you are watching or you are observing this 6 kg mass. Will this 6 kg mass will appear to you as point mass, or means very, very, very small mass, or very, very, very small size you will see of this mass?
yes,
No,
small size, right?
no. But when you will stand here, but this 6 kg mass is at a distance of 10 kilometer. Tell me one thing, when you will observing this 6 kg mass from here, and when you are observing this 6 kg mass from here, for you the condition will be different or not?
Yeah.
Obviously, this mass will be somewhat larger. Larger means you will observe this mass as larger as compared to here. Here, when you will see this mass of 6 kg, this mass will become a point for you.
Yeah.
That is why we are saying point masses. So basically, these two masses will be considered as point masses. Same concept we can use for the point charges. Suppose 1 coulomb charge and 2 coulomb charge are separated at a distance of 1 meter, and again these charges will not point charges. When these two charges, 1 coulomb and 2 coulomb, 10 kilometers apart, or you can say 1 kilometer apart also, so these two masses will be considered as point masses. Point charges, sorry, this time.
Point charges.
So basically, this concept is purely depending upon the distance. No one can say this charge is point charge.
Yeah.
That will be depend upon the distance. Totally.
So can I take a picture or later?
So I will give you time. I will give you time after completing this topic.
Yeah, okay, sure.
So the meaning of these charges are the point charges. Now clear? Okay. So these two
Yes.
point charges, Q1 and Q2, separated by some distance R. Then the force of interaction. Force of interaction means between two charges, the force can be attractive or the force can be repulsive. So this force is depending upon, force is directly proportional to the product of two charges. Force is inversely proportional. F means force. Force is inversely proportional to R square. And here, this force depends upon the medium in which charges are placed. Force acts always along the line joining the two charges. These two charges. Okay. Force will always act along the line joining the two charges. Now, let me explain this point. Suppose this is one charge. This is another charge. Okay. This is charge Q1. This is charge Q2. So now, suppose this is positive charge and this is also the positive charge. Both are positive charge. So both are positive charge and they are separated by, suppose, some distance r. So obviously they will repel each other. So they will repel like this. Means the force will act along the line joining the two charges. The force will not act like this. Understanding? So this is wrong and this is correct. So this is the meaning of this point. Force act always along the line joining the two charges. Okay. Okay, so suppose this is equation number 1 and this is equation number 2. So when you will combine both the equations like we did in the gravitation, so you will get the force is depending upon or directly proportional to Q1 Q2 divided by R square, and this force will become this. When you will remove this proportionality constant, when you will remove this sign of, this is the sign of proportion, direct. Okay, when you will remove this proportionality sign, you will get a constant, and that constant is equal to this 1 upon 4 pi epsilon suffix m, like epsilon suffix m. So this is epsilon suffix m is known as the permittivity of medium. That medium can be air, that medium can be oil, that medium can be glass, that medium can be any gas. Okay, and the value of k is 1 upon 4 pi epsilon m. So when you will put this value here, so you will get, what you will get? You will get F is equal to 1 upon 4 pi epsilon m multiplied by Q1 Q2 divided by R square. Now, if I am saying to you that both these charges are separated in air, so we will take now one special case. We can, I am not saying this is a special case. Okay, so basically, when charges are placed in air, suppose this is charge Q1, this is Q2. This is Q1 and this is Q2. And these two charges are separated or placed in air. So in that case, na, what will happen? Force you will calculate K Q1 Q2 divided by R. You will calculate the force K Q1 Q2 divided by R. What is the value of K? I told you 1 upon 4 pi epsilon of the medium. But what is the medium now? Here, what is the medium? Air is the medium. And for air, the absolute permittivity of the medium will be known as epsilon naught. We represent for air, epsilon m is equal to epsilon naught. This is a way of representing. So this epsilon m become epsilon naught. So this formula will change. And the value of this K in air is 9 into 10 to the power 9. And epsilon naught is the permittivity of air. Basically, you can say this has absolute permittivity of air. This is the property, absolute permittivity is what? Property of the medium. Property of the medium. And the value of epsilon naught is also given by 8.85 into 10 to the power minus 12. This will be given to you in the question. Sometimes in 90% cases, this value will be given to you in your question. But this value you have to remember. The value of 1 upon 4 pi epsilon naught, that is K. So finally, then you will get this formula F naught. F naught is the force between two charges in medium. So this force can be attractive and this force can be repulsive. What is F naught? F naught is the electrostatic force between two charges in air. Electrostatic force between two charges separated in air or placed in air. Air, or you can say vacuum. Air, or you can say vacuum. Or you can say this is valid also for the free space. So you can write this value for air or for vacuum or for free space. Vacuum or free space, same thing. So air, vacuum or free space. So we consider the air around us, the effect of the air on the electrostatic force we considered as 0. We assume there is no effect of the air on the electrostatic force due to the charges. So that is why we are saying vacuum. That is why we are saying free space. Vacuum means now here I am sitting and around me there is air. And air is in air there are different types of gases. Nitrogen, oxygen. Mostly nitrogen and oxygen gases are there, 70% and 21%, and other gases also, inert gases are also there in here. So what I want to say that around me air is there and gases means gases are around me, and gases is made up of matter. We know that matter have 3 states: solid, liquid, gas, and there is one more state that I will not discuss, that is plasma state. But basically 3 states are, we will discuss 3 states: solid, liquid, gases, matter. 3 types of matter: solid, liquid, gases. And matter is made up of Matter is made up of particles or atoms. Made of atoms. Atoms means particles. So around me there is air, means there are particles around me. So if you have taken a vacuum cleaner, vacuum pump, or somehow you removed all the air around me, so will there be any particle? No. And that condition is known as the vacuum condition. Means when there is no particle, free space, no gas, no air. Now limitations of Coulomb's law. Limitations of Coulomb's law. This law is valid for 2-point charges only. This law at one time is valid for only 2-point charges. Same as that of law of gravitation. Law of gravitation is also valid for 2-point charges taken at a time. And another thing, this law is valid only when 2-point charges are at rest, or this law is valid when one of the point charges is at rest and another charge is in motion, but the distance between them is fixed. So this is a special case. So remember this note point. This is very, very important. This law is valid when one of the point charge is at rest and another charge is in motion, but the distance between them is fixed. So I think we should change this statement. This law is valid when valid only when one of the point charges is at rest. Okay, so, but you can manage it, I think. So for example, this is the case here. This is the case here. We know that this is atom, suppose. This is atom, and this is at center, nucleus is there. At center, positively charged nucleus is there. And around nucleus, electrons are revolving. So electron will be here. And this electron is revolving in circular orbit with some speed v. Electron is revolving around the nucleus. So now you can see this electron is revolving. So means electron is a charge, nucleus is also a charge. Nucleus is having positive charge and electron is having negative charge. Do you know structure of atom, Shafuddin? Do you have any little bit idea of atom? Means inside atom, at the center,
Yeah.
it is assumed that there is a nucleus and electrons are revolving around nucleus in circular orbit, and inside nucleus there are protons and neutrons. So basically here this is the atom. At the center of the atom, positively charged nucleus is there, and in circular orbit electrons are revolving. So this electron, I am taking one electron. So this electron is revolving around this nucleus in the circular orbit, and this is the nucleus. So basically see this as two charges separated by some distance. Suppose this distance is r, small r. So if distance is small r, this is one charge, this is another charge. This is one charge, this is another charge. So basically you can write this statement like this. I am modifying it a little bit so as to understand more in a better way. So now here is the nucleus, positively charged nucleus. Oh, sorry. Here is the electron, negatively charged electron. And here is the nucleus, positively charged. Okay. This is nucleus and this is electron. They are separated by some distance r. So consider this as Q1 and consider this as Q2, because these are two charges now. So when you will apply the Coulomb's law, so it will become F is equal to constant K, Q1, Q2 divided by R square. And remember, this electron is revolving. So basically, this is the F. What is F? F is the electrostatic force. And for the motion of electron in this circular orbit, what is the requirement? What is the requirement? When any body or when any particle is moving in a circular path, which force is required? Centripetal force, no? And that centripetal force is provided by some other force. So here that other force is this electrostatic force. So electric force, or you can say electrostatic force, will provide the centripetal force. Centripetal force for circular motion of electron. Circular motion of electron around nucleus. Try to understand, try to connect the dots. Now you can take these screenshots one by one. So the topic is just a minute. Actually, I have to do this a little bit up. Okay, now you can take the screenshot. Remember, here this C means coulomb, unit of charge.
Done, sir.
Hmm.
So is my voice clear or not, sir?
Yeah, your voice is clear. Is my voice clear?
Yeah, I can hear.
Okay, now you can take a screenshot of this.
Done, sir.
Okay. Now you can take the screenshot of this. So just a minute. Take this.
Done, sir.
This one.
Done, sir.
Okay.
Done, sir.
Okay, so this is done already. So now basically what you have to remember, you have to remember that if two charges are placed, Q1 and Q2, these are the point charges and these are separated by distance R. Which formula you will use? Force between two charges is given by K.
K Q1 Q2 by R.
R square.
R square.
And the value of K is 1 upon 4 pi epsilon m. And for air, you will use the value of K as 1 upon 4 pi epsilon naught. And this value is given as 9 into 10 to the power 9. So we will now solve some of the numericals.
So
First
is there like a particular value for epsilon or no?
Yeah. 8.85 into 10 to the power 11.
Oh, okay.
This here, this is covered here. 8.85 into 10 to the minus 12. Sorry. Okay. If there will be a requirement, then we will use this 8.85 into 10 to the power minus 12. There is a unit also, so we can calculate the unit also for this epsilon naught. Okay, so but it's okay. You can find that. So now this question. This is very easy question. It is given that calculate the force between 2 point charges, each of 1.0 into 10 to the power 9 minus 9 coulomb, which are 4 centimeter apart in vacuum. Which are 4 centimeter apart in vacuum. Vacuum means free space. And for free space, what is the value of epsilon m? Epsilon naught. And the value of K becomes 1 upon 4 pi epsilon naught. And this value becomes 9 into 10 to the power 9. So directly we can use. So you will apply this formula. F is equal to, basically two charges are there. Similar charges. Two charges like this. This is Q1 and this is Q2. Q1 value is this 1 into 10 to the power minus 9. So you can write this as 10 to the power minus 9 coulomb only. This is also written as 10 to the power minus 9 coulomb. See, the magnitude of the charge here is very small. That is why we are saying this as a point charge. And they are separated by 4 centimeter apart. These are very, very small magnitude of charge. 4 centimeter apart. So for these charges, these small charges, this 4 centimeter is also a very big distance. If the charge is of 1 coulomb, then I will say the 4 centimeter will not be the distance for which we can consider 1 coulomb as a point charge. So these are the point charges. If given in the question, so no need to apply, means no need to think much. If given in the question point charges, apply the Coulomb's law. It is given here point charges. So F is equal to, they are placed in air, na? Oh, sorry, vacuum. Vacuum, na? So you will apply K, Q1, Q2 divided by R square. What is the value of K for vacuum? 9 into 10 to the power 9.
9 to 10 to the power 9.
This is for vacuum or air. So it is 9 into 10 to the power 9. Q1 and Q2. Q1 and multiplied by Q2. So it is 10 to the power minus 9 multiplied by 10 to the power minus 9. R square. 4 centimeter square. So you will convert the centimeter into meter. So R value is 4 centimeters. So R is 4 centimeters. So you will convert this as 4 into 10 to the power minus 2 meter. In 1 centimeter, 10 to the power minus 2 meters are there. So it will be 2 into 10 to the power minus 2. Oh, sorry, 4 into 10 to the power minus 2. And square of this. So now this one and this one means this 10 to the power plus 9 will be cancelled out with 10 to the power. Okay, this will be cancelled out with this. So you will have 9 into 10 to the power minus 9. And in denominator you have 16 into 10 to the power minus 4. So what you will have? 9 by 16 into 10 to the power minus 9, and it will be plus 10 to the power 4 when this value will go in the numerator. So it will become 10 to the power minus 5. So now you can calculate this. Use the calculator. It will be 16, 9. 80, and this is 10, 100. So it will be 0.56 into 10 to the power minus 5. So you will get 5.6 into 10 to the power minus 6 Newton.
Yes, very famous.
Another question? Shafruddin, just try this question by yourself. Value of K, here you will use 9 into 10 to the power 9.
So over here, try using red 1 over pi.
What?
I used the epsilon not.
No, this is K. K is this, na?
So
K
it's
is
Q1, Q2 by R square.
1/4 pi epsilon naught.
Epsilon naught.
And force between the two charges is K Q1 Q2 divided by R square. Electrons are there and charge on the electron is given. Completed? Okay, now see. I am solving. See. They are saying calculate the force between two electrons which are 10 to the power minus 10 meter apart. So two electrons are there, na? Means two charges are there. Electrons means charge particles. One electron is here, another electron is here. I will represent electron like this, P and minus. So Q1, you can consider this as Q1, consider this as Q2. And what is the value of Q1 and Q2? 10 to the power minus 10 meter. So this value is 10 to the power minus 10 meter. 10 to the power minus 10 meter separated by a distance of charge. I have to write here, not a distance. Sorry. So 10 to the power 10 meter apart they are. Charge is 1.6 into 10 to the power minus 19, and this is negative. Now put the value. K is K Q1 Q2 divided by R square, na? So value of K is 9 into 10 to the power 9. Q1 is minus 1.6 into 10 to the power minus 19. Q2 is minus 1.6 into 10 to the power minus 19 divided by R square, means 10 to the power minus 10 square. So when you will do the calculation, you will get the answer in Newton. So these are two electrons, Shafdi. So will they repel each other or will they attract each other? these electrons?
Are they like poles or
Repel like this. Why? They have a same charge.
simple?
So they will repel. So this will be the force of repulsion. So force is a vector quantity, na? So the force is vector quantity. So that is why direction of the force is also required. So direction of the force is away from the charges. Means like this. Not away from the charges. Like this will be the. Means they will repel each other. Okay. So fast take the screenshots. Then rest of the things we will discuss in the next class.
Done,
Take
sir.
this. Done.
Yeah, done, sir.
Take this screenshot. Okay, so revise this. Okay, in the next class we will start the electric field.
Okay, sir.
Okay.
Sunday, how about the class, sir? Morning or evening?
Are you free in morning?
Morning what time, sir?
Morning means it is